Welcome. In this tutorial we are going to learn about generator. Generator is a function when called returns a generator iterator object that behaves like an iterator with the state preserving using yield. Generator is a special function that simplifies iterator implementation for the user defined class. Yield keyword transforms normal function into a generator function. And generator does not hold all the values in the memory. It can create values on the fly. When execution reaches the yield, it returns a value and the state of the function, including local variables and code pointer at which yield occurs, is saved and function is paused. When the next function is called on the iterator object returned by the generator function, the function is resumed, and this state preserving of generator function is implicitly managed by the Python. And when generator function is interpreted, it implicitly implements the iterator interface, which makes generator function compatible with the for each loop. And when all items are exhausted, it automatically raises the stop iteration, so no need to manually raise stop iteration or to write a return statement. Now let's write a generator function which works like a range function we use with the for loop. So here is generator function gen, which takes one parameter and it iterates while loop beginning from 0 up to the given number n, and at each iteration it yields the value of I and it increments the value of I. So this yield statement transforms this normal function into a generator function. So when this function is called, it will return a generator iterator object, and at each iteration when the next method is called, the value returned by this yield statement will be received by the for loop or the returned by the next function. So let's create an iterator object of this generator function. So here we are calling this generator function, so it will return a generator object and we will introspect how the generator function and the object returned by it looks like. So let's execute it. So here we can see this function is a normal function with the yield statement that makes it a generator function, and when it is called, it is returning object of type generator object. Okay, and if we see the generator object, it contains iter and the next method which we saw for the iterator interface. So this object can be used for the for each loop to iterate over the elements. So let's invoke next method on the generator object, which will return the value of the I at each iteration up to the given n. So here we are passing the value 3, so it will return 3 value, and when we invoke next fourth time, it will automatically raise stop iteration error, which will end the for each loop. Same we can generate using for each loop using our user defined generator function gen, and if we execute it, as we can see, it is generating the number of values given to it. So when the execution reaches the yield statement here, when calling the next, it returns the value and all the local variable. For example, for this function, the local variable is I, and the location of yield statement is preserved implicitly by the Python. So when the next function again is called on this generator object, it automatically resumes from this statement onwards. So it will increment this I, and again it will resume from the while loop, and it will come here, and again it will yield a new value, and after yielding the value, it will preserve its state again. Next is collecting values of generator into a collection. So from the generator object, we can collect value into the any container such as list or set. So if we execute, as we can see, all the values that can be iterated over using for loop is collected into the target container type. So when creating this object, this generator object does not contains all the value by default. So when calling the next, it generates the value, and when calling this container or collecting into the container, it iterates over all of the iteration and returns the value. But object itself does not contains all the values, whereas container type such as list holds those value, and when we are iterating over it using iterator protocol or iterator interface, it already contains all those values. Next is applying function on a generator iterator object. So we can also apply functions like sum or maximum on the generator object, which will return the value from the all of the values returned by the generator function. Now next topic is generator expression. It is an expression which returns generator iterator object. It is working is same as the list comprehension, but rather than performing an operation on the all element at once, it performs operation on the fly when the next method is invoked, and it enables the iterating with the infinite stream of data, which is not possible with the list comprehension. And it can also be used for returning a generator iterator object for the collection, or performing some operation on the each element of the collection, or selecting subset of elements from the collection. So let's first write a generator expression for creating a generator object from the collection. So here we have list, and here this we are writing a generator expression. So when this expression is executed, it will return a generator iterator object, which will iterate each name from this names list. So we can iterate over this object written from this expression using for loop. So as we can see here, if we after executing this expression, if we check the type of object, it is a type of generator iterator, and here we have iterated over the each value of this iterable object. Now let's apply some function on each value of the collection. So here, as we can see, we are iterating over each value of the collection, and when returning we are applying this upper function, which will convert this string into the uppercase string. So when we are iterating over it, it will convert this string into uppercase string on the fly when it is calling the next function at each iteration inside this for each loop. So let's execute it. As we can see, it is converting all the strings inside the list into uppercase string. Now we can also filter the values from the collection using generator expression. So with the same expression in previous example, we can attach if statement and the condition. So all the strings which satisfies this condition written after the if statement, only those values will be returned by this GeneratorIterator object. All the other values will be discarded. So here the strings only starts with J will be returned by this GeneratorIterator object, and it will be converted into the uppercase. So as we can see, it returns only two strings which are beginning from the J. Now let's create a generator object using generator expression from the generator function. So as we can see, inside the generator expression, we are iterating over the generator function range, and we are returning the value returned by the range function at each iteration, and we are transforming that value into other value. So this value, after for each value returned by it, it will perform this operation and it will return the result value at each iteration. So as we can see, for each value it is invoking this expression and the return result of this is returned. So as we can see, it is generating odd numbers. Next is generator expression versus list dictionary set comprehension. So list dictionary set comprehension generates the whole result in the memory and passes results to the target container type, whereas generator expression yields one result at a time when the next method is called on the iterator object, and it does not creates all the values in the memory. It generates value on the fly. So for example, in the previous section, writing this expression returns the GeneratorIterator object, which does not produces all the items when they are iterated. So when writing for each loop at each iteration, it will generate one value and it will store its state, and when the next function is called on that object, the function resumes its execution and generates the next value, okay, until all the elements are exhausted. And when writing this list comprehension, it generates all the value and it stores those value into the target container type. So that is the main difference between the generator expression and writing a list comprehension. Now we will write a generator function for the iter method of the user defined class. So we can make the object of the class iterable using generator function. So as we can see here, the class contains collection of students and we want to support the object of the class to be iterable. So we have written this function as a generator function because it is having yield statement. So what it does, it is iterating over the each student in the students collection and yielding the one student at a time. So when we are calling the iterator, we know that this dunder is called when the iter method is called on the object of this class. So when calling this method, it will return a generator iterator object. So that object will iterate over each student and it will automatically preserve its state. So we don't need to implement here the next dunder because that will be implemented by the object which will be written by this dunder iter call. So as we can see how much less code we have to write in order to make object of this class iterable. So here we have created students and we are storing this students inside the class. So students are stored in the dictionary object. So it will return one entry of the dictionary at each time when it is iterated. So here, as we can see on the object of class, we are invoking iter method which will invoke this iter dunder and it will return the generator iterator object. So if we check the type of object written by this iter, so generator1 is a type of generator iterator object. Now we can iterate over this object. So we can invoke the next method which will return a student. So as we can see here, invoking the next, it is returning the one entry from the dictionary object. Same as at each time it will call next, it will return one student entry until it is exhausting all the students. So all this state preserving is implicitly managed by the Python. We are just writing the business logic what to return at each iteration. And if we create multiple simultaneous iterator, it is implicitly supported by the Python. So as we can see, invoking next on the generator 2, it is beginning from the first student. And as we can see, after third iteration, it is resuming from 104 and generator 2 is resuming from 102 after invoking it for the 2 times. Next is using generator expression to return a generator object on calling the dunder iter. So earlier we wrote for each loop which is iterating over the each items of the dictionary. Now we will write generator expression inside the iter dunder. So as we can see, we are just writing a generator expression which is same as we wrote for each loop, and we are returning it when it is called the iter method on the object of this class. So it will automatically return a generator object. So within single line we can make object of the class iterable. So using the same object we will create an iterator object. So as we can see, it is returning a generator iterator object, and when it is iterated using for each loop, it is returning the students which are stored inside the collection. Now next is unpacking generator elements as a function argument. So we can unpack the generator argument such as this range is a generator function. So it is taking variable number of positional argument, and we can unpack all the values that can be written by this generator function using this star. So it will unpack all the values, and those values will be passed as a positional argument or the variable positional argument to this function, and it will print the values. So as we can see, these are the values which are unpacked by this expression. Next is generator calling other generator function. So inside the generator function, so this is a generator function we wrote earlier. So the same function can be called inside another generator function. So it is yielding, which means this function is a generator function and it is calling other generator function inside it. So using this generator function, all the functionality works as the normal generator function works. So as we can see, it is returning 10 values from this generator. Next is infinite generator. A generator which generates infinite values. So earlier we saw we were passing the number at which it stops iterating. So whatever the number we were passing to this function, it generates the given number of values. But with the generator function, we can write a generator which generates infinite value, and it stores the local variable implicitly, so we don't need to write any explicit code for preserving state. So here is a generator function for Fibonacci series which does not require the value at which it needs to be stopped. It will automatically give you the next value when you call the next function on the object of the generator function written when it is called. So here, as we can see, the infinite while loop, and it is yielding a value at each iteration, and it is storing or exchanging the value for the next iteration. Okay, so let's create generator iterator object for it and call the next method on the generator iterator object. So as we can see, whenever the next method is called, it will return the next Fibonacci number in the sequence, and it will exchange the value of the internal local variable, and it will automatically save the local variable when yielding a value, and it will resume at each time when the next function is called. So again, if we are calling the next method, as we can see, it will resume from the previous values and it will continue infinitely. Next is generator object methods. So it is having following methods. First one is send method. It resumes the generator execution and sends the given value into the generator function and returns a new value yielded by the generator function. So using this value on the generator function, which is returned when calling the generator function, you can pass the value inside the generator function. And using close method, it closes the generator function and it frees all the resources acquired by the generator function, and it raises the GeneratorExit exception when the generator object is closed, and this exception is managed internally by the generator function. We will see it with the example. Next function is throw. It raises an exception of a given type as a first argument when the generator is paused and returns the next value generated by the yield statement. So this exception, which is raised by the throw function invoked on the generator iterator function, will be passed to the generator function, and generator function has to handle this exception, otherwise it will propagate to the main program. And after raising it, generator is paused and it returns the next value yielded by the yield statement. Now, as we saw earlier, the generator function raises the stop iteration error when all the elements are exhausted. So same can be used using return statement of a function, but there is a slight difference. When an exception is raised by the return, the stop iteration, it cannot be caught by the try except block, whereas the exception raised by the raise stop iteration, if you are raising it manually, then it can be caught by the try except block. So you don't need to raise it manually, but when certain conditions are raised, then you can use stop iteration or the return statement. So when you are writing return, the exception which is raised by the stop iteration by the Python, it cannot be caught. And if you are raising using the raise stop iteration syntax, then that can be caught using try except block. And return X inside the generator raises the same stop iteration with the given value, which exits the given generator function. So here we will write a return statement inside the generator function. So when the value will of the I local variable reaches to the maximum value, it will return with the given last value. So let's execute it. So as we can see here, after returning 5 values, it will execute this return statement, and it is raising stop iteration with the value 5, at which it must stop. Same way inside the for each loop, as we can see, it will only iterate up to 5 values. Now next topic is yield from. When iterating from generator inside another generator, you can use yield from instead of iterating over using for each loop. So here we have generator which works like a range function. So in order to iterate over all the elements of this generator inside a generator, you can use yield from and the generator name, which will return all the values one by one when it is calling the next function on the generator object. So let's invoke it. So as we can see, when invoking this generator function, it is yielding one value at a time from the given generator. Next, you can write multiple yield statement inside a generator function which will execute yield function serially. So for example, this function has multiple yield from, so it will first return all the values from the first generator function. Then after exiting from this generator, it will return all the values from this generator. So as we can see, first we are seeing from 0 to 9 numbers for this generator, and from the square generator these values are written for the first 10 values. So it serially execute all the yield from for each generator function. Next is chaining generators. So generators can also be chained in order to achieve the target business logic. So here, as we can see, for example, we have written generator function to remove blank spaces, to convert a string into uppercase string, and to iterate over the collection of string object or the list of string. So all this generator function can be chained like this using. So first generator function will iterate over the list of string, then outer generator function will convert each string into the uppercase, and the outermost will convert a string into the uppercase string. So it will return, when chaining like this, it will return a generator object, and when it is iterated on each call of the next function, it will transform this value going through this all of this generator function. So for example, calling on next method on the first time, it will take the first element of this collection names. So it will return this string, and that string will be converted into the uppercase, and then it will be removed blank spaces, and the result string will be returned by this next call, and it will stop there, or it is paused there until the next method is called again on this iterator object. So by making this chain of generator, we can modularize the business logic, and it also supports the reusability of the logic. And it works like assembly line in the production, where at each station performs its unique operation, and after passing through n station, the finished product comes out. So as we saw for this example, when processing one string, it passes through the multiple function, and as it is the generator, it does not converts all the values when writing this expression. Okay, it will generate value on the fly when the next method is called. So let's execute it. So as you can see, on the each next call, the given string is going through this function and returning the final result string. Now next is passing the value to the generator function. So earlier we saw generator object has the send method, and you can pass the value to the generator function. So when invoking the send method, the value given to it is passed to the generator function, and it will yield a value which is returned at each iteration. So here this generator function returns the value of the local variable x. So if we invoke a send function on the generator object, when returning the value, whatever the value will be passed to it will be returned by this yield. So we can store it inside a local variable, and here we are checking if the value passed to this, or the value returned by this yield, is not none, then we are storing it inside the local variable x. So on the next time, it will continue from the given new value instead of resuming from the old value. Okay, so here this generator will begin from the value 5 to increment, and after sending this value, if we are calling the next value, it will be returning the value based on the value passed by the send function, because we are storing that value passed into the local variable x. So let's execute it. So as you can see, it is beginning from the value 5. At each iteration, it is incrementing value by 1. So when sending this value, it will store this value inside the x. So x is having the value 100, and we are yielding this value x, because in this iteration it will not go to the else block. So when yielding this, yielding the previous value is overridden by the new value 100. So it will invoke this if statement and again go to the while, and here it will yield the value x. So when calling this send function, it is returning the value 100, and when the next time it is calling the next function, it is returning the value incremented by 1. So the next time when we are calling the next, it will not pass the value, so it will having the none value, so it will go to the else block and it will return the value incremented by the previous value set to the variable x. Next is using try except finally inside the generator. So generator function can receive an exception which can be thrown on the generator object. So earlier we saw it has a throw method. So we can cover the generator business logic inside try except block. So whenever the exception is raised on the generator object, it can be passed to the generator function, or the necessary steps can be taken when the certain exception is raised. So here, as we can see, the order processing logic is wrapped inside the try except block. So whenever the value error will be thrown by the iterator object, this except block will catch it. And we also have the outer try finally block, which will ensure that whenever exiting this generator function, the logic written inside the finally block gets executed. So let's execute this generator function first normally for all the order. So as we can see, it is processing all the orders given to it normally, and after executing it normally, it is executing the statements inside the finally block of outer try finally, and this is the statement after the try finally. Now when iterating over the objects of the generator iterator object, if we break out of the loop without finishing, then as we can see here, it will print this message and it will break out of the loop. So it will close the iterator object. Same can be done by invoking close method on the iterator object. So when the close method is invoked, it will break out of this loop and it will execute the content of the finally. So as we can see here, when executing close on the generator iterator object, it is exiting. Okay, and it is invoking the content of the outer try finally block. And here one thing to notice it, for the both example, it is not executing this print statement after this outer try finally block. Why? Because it will raise a GeneratorExit exception when you are breaking out of this loop or you are closing an iterator object without finishing all the iteration. Okay, so this last function or the statement after this try finally block is not getting executed, whereas for normal for each loop, as we can see, it is executing. Now we will throw an exception which will be passed to the generator function, and this generator function, as we can see, it is handling value error, so it should print this message. So if processing any order, if it is generating an exception, that exception can be passed from the outside to this generator function so that it can handle that exception. So here it is handling that exception, and it will resume order processing even after one order is having exception with it. Okay, so it will continue processing other orders. So as we can see here, so order with order ID greater than 200 will raise this exception here. So it will throw this value error exception. So as we can see here, it is raising an exception, and if we see this, it is printing that invalid order processed. So it is handling this exception thrown by the for each loop, and after handling this exception, okay, it is yielding the order. So that order number is yielded, which has raised the exception, and after yielding it, it is again starting the processing the next order, okay, into the from the given orders list. So it will continue even after throwing the exception, because that exception is handled internally by the generator function. Okay, and it will exit gracefully, and this is the print statement after the outer try finally, and this is the print statement after the for each loop here. So as we can see, you can write try except finally inside the generator function. Now next topic is GeneratorExit Exception. It is raised when generator function is closed using generator.close method or writing a break statement inside the for each loop. And we can catch this GeneratorExit exception because it is a subclass of this base exception class. Okay, so here we have try except block, and except block is catching the GeneratorExit exception. So we can write a logic when exiting the generator. Okay, it will only be generated when you are not fully iterating over the sequence of the generator object. If all items are exhausted, it will raise stop iteration error. So when abnormally terminating this generator iterator object, this exception is raised. So here this generator function will print the last order it has processed when exiting abnormally. Okay, so let's execute it. Here we are breaking out of this for each loop. So as we can see here, this GeneratorExit exception is caught, and it is printing GeneratorExit while processing the order. The same message we have written inside the except block. And it will also execute the print function written after the try finally block, because we are exiting the generator normally by catching the GeneratorExit exception. Same way, if you are closing the generator iterator object here, then also this generator exit exception will be raised. So same here, we can see it is printing the message inside the except block. So that brings us to the end of the video.